In our last video, we spoke about exposure. Exposure is the overall lightness or darkness of an image. The exposure of a photograph is determined specifically by the amount of light that reaches the camera sensor when we take a picture. There are three camera controls we can use to hold back or let in more light. These camera controls are the ISO setting, the f-stop or aperture, and the shutter speed of the camera. With that, let's take a look at how each of these three ideas work together so that we may choose settings interchangeably to help get the light to where we need it to be. To start off with, let's take a look at ISO. And just a reminder, the ISO is the sensitivity of our camera sensor. So we can make the sensor more sensitive if we're in a low light situation, and we can make it less sensitive if we're in a bright situation like a bright sunny day. Our common ISO settings on our camera are 100, 200, 400, 800, 1600, 3200, and on newer cameras 6400. These numbers may be familiar to anyone who shot film, as these would be the film speeds that we used to be able to buy, the exception being 6400. But other than that, you could buy a 100 speed film or you could buy an 800 speed film. Nowadays with digital photography, there's a great benefit that we can choose an individual ISO for each picture that we want to take. Previously, photographers would be committed to stay with the ISO throughout an entire roll of film. So for 36 exposures, they would be stuck with the speed of film that they bought. So it's really a wonderful benefit that nowadays we can just change that ISO as we move through the world and move in and out of different lighting situations. After that, we have, again, the f-stop, or aperture is the more scientific word. More common language is f-stop though. And again, let's just remember that series of numbers as well. Very fast lens will have 1.4, but not all lenses will. It's very common nowadays for consumer lenses to start at f4. It just allows the manufacturers to make a lens that's more affordable so that they can keep it at a consumer price point. And some lenses may go up to 32, but that's not so common anymore. After that then, the f-stop and aperture will be the opening in the lens. And the last camera control that we use when taking a picture is the shutter speed. And again, the shutter speed is simply how long does the light get to hit the sensor. So our shutter is literally a curtain of black metal that keeps the light off of our sensor when we're not taking a picture. It's geared mechanically so that it opens and closes for a very specific amount of time that corresponds with the shutter speed setting that you've chosen when you take a picture. Again, that series of numbers will be 1, 2, 4, 8, 15, 30, 60, 125, 250, 500, and 1,000 is a good stopping place. Newer cameras will continue all the way up to 8,000, but you certainly will get the idea at 1,000. Alrighty, so now with each of these settings, when we look at the numbers specifically for ISO, we notice actually that they double from one to the next. And that is for a very particular reason. Let's go up here and make a little bit of room. Sorry about that, bear with me. So in photography, you probably have heard a photographer use the word stop before. And that word means something very specific. A stop is a change in light by a factor of 2. So if we're going towards more light, then we're doubling the light. And if we're taking light out of our exposure, then we're cutting our light in half. And as we move through these camera controls, from one number to another, we are making a change in our light by a full stop. We'll talk about the fact that your cameras nowadays have additional numbers in between each of these. We'll go through that. There's a reason for that. But on an old film camera, these are the numbers that you would have seen. And moving from 100 to 200 is going to double the light. 200 to 400 will double the light. So with that then, ISO is really easy because it's quite clear both in idea and numerically. When we move towards, remember we'd said our higher numbers were faster. That means more light comes into the exposure. And of course our lower numbers will be slower. And that means less light comes into the exposure. So as we move from a lower number to a higher number, we are doubling our light. Likewise, if we move from a higher number to a lower number, we're cutting the light in half. Now, when they set up the camera controls, someone was actually smart enough to realize that if changes in ISO, f-stop, and shutter speed were all by the same amount, that we would actually be able to use these controls interchangeably. So with that, while we are always taking a meter reading and we're confined in one way to set our camera control based off of how much light we specifically have, we actually have a little bit of choice as far as how we get to the proper amount of light, if you will. So it's a combination of dealing with the reality of the light we're shooting in, but still having a little bit of freedom to make some aesthetic choices. In a future video, we will talk about the fact that the specific ISO that you use or any of the specific settings in any of these 3 camera controls will actually affect the look of your photograph slightly. So we'll go through in a future video and break down what that means and why a photographer would aesthetically want to choose to use a slower ISO than a faster one, or they may want to use a f-stop number that has a lower number as opposed to a higher number, etc. So as I say, the important thing right now is to realize that a change in setting in ISO, f-stop, and shutter speed will all produce this effect of doubling the light or cutting the light in half, depending on which way you go. Alright, so moving on to our f-stops then, the numbers are a little less obvious, but they are still actually there. The pattern is actually there as well. I realized I forgot one. So let's put 1.42 and 2.8 was our missing f-stop. Now if you look at these numbers, you'll realize that if you skip every other number, the numbers will double themselves numerically. 11 is a point where we make an exception. We should have a 0.2, but we drop that out. Same thing is true here. So 2 doubles to 4, 4 doubles to 8, 8 doubles to 16, and so on. So really, if you're ever asked to provide this series of numbers, if you remember 1.4 and 2, and you remember the pattern that you skip every other number, it's really very easy to write out this string of numbers. Alrighty, let's get these extra marks out of the way for right now. Alrighty. So with that then, remember that we'd said our lower numbers were larger openings and our bigger numbers are smaller openings. In that way, it's kind of opposite of what I instinctively think it should be. So going towards this way then is going to be faster. And again, we mean that lets more light in. And going this way is going to be slower. And that, again, is the same as less light. So the same sort of thing is true. Now, while we skip f-stops numerically to be able to draw out this list of numbers, in terms of changes in light, all we have to do is go from one f-stop to the next to be able to double the light or cut the light in half. So again, coming from a place of more light, an f-stop with a lower number, when we go towards a higher number, we're moving towards less light. So a change in light by one stop is going to cut the light in exactly one half. Opposite is true if we start with a larger f-stop number and we go towards one with a smaller number, then we are doubling the light. And as you might expect, the same pattern holds true with the shutter speed as well. So again, the numbers here, they pretty much just numerically double themselves. We just have a couple of exemptions that we need to remember, and those will be 15 and 125. Remember before that we had said these numbers are the denominator of a fraction. So when we have a smaller number, that's going to be longer. A longer time that the shutter is open, so that's going to be more light. And again, a higher number is going to be a faster period of time. So 1/1000th of a second is a pretty short, quick period of time. So that means then it's going to be faster, which is going to be the same as less light. And then all we have to do, once again, is move from a number, when we move from a number that's higher, which is less time, to a number that's lower, which is more time, we're letting more light in. So from one of these numbers to the next is going to double the light. The last thing then, of course, would be if we went from a longer period of time to a shorter period of time, we are going to be cutting that light in half. So with that then, essentially we will meter, and we will decide which of these factors is important, and then we will use our meter to find the proper setting for the camera controls that are not so important in terms of the look of the photograph. Let's just go through a couple things real quickly before we finish out this video. And I wanted to give you guys some visuals. Here we have a series of pictures that is a difference of ISOs. So in the upper right hand corner here, you can see that this darker image is taken at ISO 200. That's a proper exposure. It has a nice bright highlight and a good deep shadow. And so if we keep our f-stop and our shutter speed the same and we simply change the ISO, moving one stop up to 400 will be doubling the light, and we can see how that picture gets brighter. Again, from 400 to 200, I'm sorry, from 400 to 800 is also another full stop, so that once again doubles the light. We can see how the picture is still brighter. And so this is kind of a series of what pictures will look like. Here we have a picture that is one stop overexposed. Here's a picture that's two stops overexposed. And here's a picture that is three stops overexposed. So these pictures are helpful both to kind of understand the ideas we were talking about visually, but also to help you kind of gauge how far your exposure is off when you're looking at a picture. Moving along, we have the same ideas with f-stop. We can see kind of the scientific diagrams of approximately how large those openings are in the shutter blades. And here we have a pretty good series of change. So probably right around, let's see, 1, 2, 3, 4, 5, probably right around here is a proper exposure at f5.6. Again, if we could see the picture a little bit larger, we would be looking for a photograph that had nice bright highlights and good deep shadows. But both of those tonal areas should still retain some information. So our bright highlights should have tonal information, and our deep shadows should be open enough to still show some shadow information as well. So again, if we left, in this case, if we left the ISO and the shutter speed the same, and we only changed our f-stop, we would have this amount of change in each of these pictures. As we move down, this is a picture that's 1 stop overexposed, 2 stops overexposed, 3 stops overexposed, and 4 stops overexposed. Moving up, then we have a picture that is 1 stop underexposed, 2 stops underexposed, and 3 stops underexposed. We'll talk about range of error in digital, but I really would not try to use pictures that are too much more than a stop underexposed or a stop overexposed. And if anything, it's better to have a picture a little bit overexposed. So maybe the range of error is even like a half stop underexposed to a full stop underexposed. Alrighty, then the last image to look at here will be with the shutter speed. Again, I would probably say that 1/125th gives us a nice bright highlight. Clouds are really a tricky thing. Don't judge your highlight exposure off of a cloud because there's some other things that affect the way a sky will record. So really what I'm kind of looking at is the slide right around here, and I'm kind of checking to see that this midtone is coming in as a gray as opposed to a white. Then I'm looking at the shadow up here in the top of the slide to see that it's still open enough. Arguably, we could go to this next one at 1/160th, but that's just a little bit deeper. And here, actually, I will point out that 1/100th feels a little bit deeper, but I can tell you with the cloudy sky that that's because the amount of light changed just slightly. I know that 1/125th, intellectually, I know that's a faster shutter speed, and looking at the highlight here, it's actually a harder highlight. So this simply is a matter of the cloud cloud coming in front of the sun and dropping that exposure back a little bit. So I almost would encourage you to just disregard that one and look at 1/125th to 1/80th of a second here. So, but again, the idea is still the same. If this is our proper exposure, then these are overexposures, and these are underexposures. And we can see how we're working with a positive image, so if we have too much light, the picture gets brighter. If we have too little light, then the picture is darker. Another interesting thing about this slide is you'll see some numbers that we did not include in our series of f-stops, and that leads us to one of the other things that we need to discuss in this video. So we have 1/125th. If we took another picture, we would have 2/50th, but they didn't take that picture. And we have 1/60th, and again, the next picture over here would be 1/30th. So with that then, this series of pictures actually illustrates changes in light. It gives us actually what we call differences of 1/3 of a stop. 1/3 of a stop. So you can see that we don't have to make these big full changes from one full stop to another. And let's go back to our chalkboard and we'll talk about that here in just a second. So I realized that as we're talking about exposure, we should mention the fact that you need some criteria for determining proper exposure. And let's erase this extra stuff up here for a second. Alrighty. So proper exposure, as we have all of these lectures, first of all, we are talking about photographs of what we call a normal average scene. Sorry, my computer's jamming up on me. Bear with me for just a second here. And this will actually happen occasionally. I have a first generation Lion machine, and the video card has never played perfectly. So here and there I have to click onto my desktop and then click back into Photoshop. So hopefully it won't become crippling. But we have a normal average scene. And that simply means that we have highlights, midtones, and shadows. So every now and then in photography we have pictures that are what we call white on white or black on black. And those are a very different situation in terms of exposure. So we'll deal with those a little bit later on in the semester because they require that you kind of understand the ideas behind how a camera meter works in order to actually make the decision yourself. Uh, uh, both of those, black on black photograph is referred to as a low key image, a white on white photograph is referred to as a high key image, and both low key and high key images are shooting situations where a camera will not work very well in an automatic metering mode. So those are a couple of situations where you need to actually be able to understand photography enough to shoot in a manual shooting mode and understand what it is that you need to do to compensate for the situation that you're working in. So again, I'm going to see if I can click and get this card to refresh itself a little bit more. Alrighty, we were talking about proper exposure, and as we were looking at those pictures, we were talking about bright highlights, and that is a bright highlight that still retains detail and a rich shadow. And again, we're looking at shadows that are deep but still open enough to show some shadow details. So we're not talking about just big blobs of bright solid white or blobs of heavy black shadow with no detail in them at all. We're going to look at these two areas and try to find an exposure that gives us bright highlights with highlight detail and rich shadow with shadow detail. So a couple of terms too we should talk about as we move from one f-stop to another, or when we're thinking about the idea of stops in our vocabulary. When we move towards less light, we're talking about closing down or stopping down are the terms that photographers use. And if we're moving towards more light, then we're talking about opening up. is the phrase that a photographer would use. Alrighty. And then the last thing I think that we need to talk about is the fact that each of these numbers that I give you actually have a couple of additional settings in between them. If you were looking at a manual film camera and you looked at the ISO dial, you would actually see a couple of small dots. You would see two small dots between each of the numbers printed. And each of those dots is a setting for a third of a stop of a change. So in reality, you were actually always moving that dial 3 notches before you got to the next full number. However, nowadays, with a camera that has a digital readout screen, that camera needs to assign a number to those little dots in between. And so we get ISO settings like 125 and 160th. I'm sorry, 160. That will sit between 100. And to be perfectly honest, I don't have all of the numbers for the third stop changes totally memorized because I just always thought of them as dots in between the full stop changes. So bear with me if I'm writing down an incorrect number. But so really, if I was at 100 and on a digital readout camera, a current modern day camera, you're actually going to need to click through 3 different changes to get to a place where you're a full stop different. So if you really want that idea of exactly doubling the light, you would have to go from 100 and click past 1/125th, click past 1/60th, and then land on 200. So from here to here, we'll double the light. And in between each of these, I don't know actually exactly the mathematical, I don't know mathematically what it's doing to the light exactly, because that's a little bit of thinking. And honestly, it's not really thinking that we totally need to do. But as far as developing your instincts, what I want you to know is when you go from 100 to 200, the light doubles, and you have greater control by making changes of only a third of a stop if you need that. Alrighty, so that is actually true for all of the camera settings. I know we have 5.6, and then I think we have 6, and then I think we have 7, and then we have 8. Again, old lens would have just a couple, they weren't even marked on the outside of the lens. There were just a couple of little clicks that you could feel when you moved from one f-stop to another. But on your camera nowadays, you're going to see some f-stop numbers that are different than only these numbers. But I do want you to know these numbers because think of them as kind of, really they're the difference in light by a full stop. And then, more than anything, like if I went to 5/6, if I went from 5/6 to 6, the way we used to actually write that was 5/6 minus 1/3. So it wasn't even that we ever thought about what this number was. We just knew that this was 1/3 of a stop less than 5/6. So that's about it in terms of stops and changes in camera controls. Hope that helps, and we'll continue to move through exposure in a couple of additional videos.